Hello everyone, I am Ullas Agrawal and in this video we are going to discuss question number 16th of the first mock test which is present in the NTA Abhyas app. Now NTA has done a very good job of providing hundreds of mock tests to the JEE 2021 aspirants and many students are actually taking advantage of this. However, some students because of some or the other constraint are not able to clarify their doubts, so we thought of helping them by providing a video solution of those questions. So without wasting any time, let us discuss this question number 16 of first mock test. So I'm going to share my screen. You're going to see it very soon. The question will be there in front of you right now. Okay. So you can see the screen right now. When the mass is rotated about a fixed point, mass is rotated in a plane about a fixed point, its angular momentum is directed along. Okay. Actually, it's an incomplete question because it's not given angular momentum about what. Like, is it an angular momentum about an axis? Is it an angular momentum about a point? And if it is an angular momentum about the point, then with respect to what point are we talking about? So based on the point chosen, there may be so many angular momentums, different, and that also at an angle of different angles with respect to the plane of rotation. And because nothing is given, we will just assume that there is a particle which is undergoing circular motion, and with respect to the center of the circle, we are going to define its angular momentum. So let me just share this diagram with you. So here it is. Okay. So this particle is moving in a circle. It's moving in a circle of some radius r. So let me and it's moving with velocity v. So what is the angular momentum of a particle? Angular momentum of a particle is m into r cross v. So let's say the particle is at this point A right now, and this is x-axis. Let's say this is y-axis. So velocity is tangential to the circle, and tangential to the circle means inward into the plane. Actually, I should, instead of showing this with this arrow, I think it is better. Like inward means I think we show it with cross. So that will be better, cross. And when the particle has come to this point B, we will show its velocity with dot. Actually, dot represents that coming out of the plane of the screen that you are seeing. Anyways, so angular momentum is m into what is r? R is the radius vector of the particle with respect to the point about which we are calculating the angular momentum. This point is P, about which we are calculating angular momentum. So with respect to this point, the position of the particle, when the particle is at A, that position will be r vector. So that r vector can be written as Ri because it is directed along I cap, which means along x-axis. Now velocity is inward when the particle is at A, and when the particle is at A, velocity is inward. Inward velocity means in minus k cap direction. Minus k cap is into the plane of the screen that you are seeing. Okay, so that velocity is, let's say, v in minus k. So this becomes mrv. Now I cross minus k is actually j. So this angular momentum is actually directed along j, and along j means along the axis of rotation. So with respect to the center of the circular motion, the particle's angular momentum is directed along the axis of rotation. So answer is C. Even if you don't take the particle, you take the pure rotation of any rigid body also. For example, rather than taking a particle, you just take a rod also and rotate this rod about this axis. Then angular momentum will be along the axis only. Depends actually. Now the thing is, if you take some other point, let's say if you take a point like this, then angular momentum will come out to be different. That's why I'm saying that this is an incomplete question. Have a good day.